Hi, my name is Jennifer Marsman, and in this tutorial I'll be continuing how we can use the Kaggle Titanic dataset to predict, based on some demographic information about a person, whether or not they will survive the sinking of the Titanic ship. So in the last session we saw how to get data into Azure Machine Learning. And we also saw how to kind of do the data science type stuff, to look at the data that we have, to kind of explore it and visualize it, and to do some data cleaning to get the data in a format where we can process it more easily. So we did a very, very quick high-level look at that. And so now in the second section, I want to show you how to actually break down the data and use it to run a machine learning algorithm on it. So what we're going to do from this point is we have the data now in a clean format where we can work with it. We have inputs to a machine learning algorithm, or features, and we also have outputs or label categories, and we're going to predict whether or not they survived. So the first thing that you need to do in this situation is now split your data. Now in machine learning, in a supervised machine learning algorithm, we always split our data, and here's why. You have a labeled data set that says, for these inputs, here is the output. And so typically what you do is you take the majority of the data, let's say 70%, 75%, something like that. You take that much data and actually build a model with it. So you apply a machine learning algorithm which can find the correlations between these inputs and that output. And then you've built a model and trained a model with that. But then we need to see how effective that model actually is. And so for that reason, we hold back some of the data. And the reason we hold it back is if we had trained the model on that data, like if I tell a model that, hey, for these inputs, here's the output, and then I try to test it using that same data, of course it already knows for that input that's the output, right? Because we already have told it that. So really what we want to test is how well can the model perform on new data that it hasn't seen before. So for that reason, we hold back some data, and we call that our test set. So we have training data and test data. So I'm actually going to split the data into those two sets, a training set and a test set. And I'm going to use, again, the majority of my data to do the training with so that it gets a good distribution of data. But then you want to have a decent amount with, a decent kind of spread. So that's the 30% I'm going to hold back, which I'll use to test the model. And it has those inputs and output, and then we can actually feed the inputs into the algorithm that we trained, see how well, get kind of the responses back, and then compare them to the known right answers that we already have. So that's what we're going to do now. So let's start by splitting the data. We'll go here and grab the split right here, which is under data transformation. So I'm going to split my data and then drag it right here to get that started. And we're going to split by rows. There's other ways you can split as well. You can split by regular expressions and things like that if you choose. And I'm actually going to split so what this variable actually represents is the percentage of the rows that you want coming out of this first node right here. So I'm actually going to put 70% of my data as my training data. So I'm going to use this as my training data node, and then the remaining 30% will come out of this node, and I'll use that as my test set. All right, and then you can set other things as well, like a stratified split. If you want to split so that there's an even number of people who survived and died kind of in each camp, you can do that as well. But I'm just going to go kind of random on this, which is fine. All right, so now I have 70% of the data coming out of here. So now I'm going to choose some machine learning algorithms to use. Now this can be a daunting task if you're not familiar with machine learning. How do I know, what kind of problem I want to solve? Now, I'm going to go down here to the machine learning section, and we want to initialize a model. And you can see there's actually 4 different categories of problems that we can solve here. There is clustering is an example of unsupervised learning. So with clustering, you don't need that input and output like I've been talking about. Clustering allows you to just kind of explore over a set of data and group it into different sections. So for supervised learning, which is when you have some inputs and outputs together, we can do classification or regression. And the difference between those two is you would use classification when you're grouping things, when you want to predict a discrete value. So for example, is this person going to develop breast cancer? Yes or no? Those kind of things. And then a regression actually predicts a number or a value on a continuum. So think about trying to predict the price of a stock, that sort of thing. And that would be a regression problem if you're dealing with predicting the price of a house, or how much is my energy bill going to be this month, or something like that. That's a regression problem because you may give it data, a whole bunch of numeric data, but it can extrapolate between those values to give you responses that you maybe haven't used in your training set. All right? And then finally, there's a category called anomaly detection. Anomaly detection is effective when you're trying to do something like credit card fraud detection, where your data set may consist of a whole lot of really good valid transactions that were valid credit card transactions, and only a very, very, very small amount of known fraudulent transactions, because hopefully your fraudulent transactions are very small, and then the ones that you actually know are fraudulent is going to be an even smaller subset of that. So hopefully the way it would look in your data set is that the known fraudulent transactions are a very tiny subset of your entire data set. So we will, in that case, anomaly detection is the way to go because it can account for those kind of diversity in the amount of data of when you have a lot in one category and a very small amount in the other category. All right, so what kind of problem is this that we're trying to solve where we want to predict if someone survives or not? This is a classification problem. So I'm going to expand classification, and you can see there's actually two different categories, multi-class classification as well as two-class classification. Now we are trying to predict two things, so either they survived or died, which is a binary or two-class problem. So we will use one of these two-class things. And I'm actually going to try a couple different things, right? Part of data science is actually art, where you experiment and explore different algorithms and see how they perform on your particular data set. So I usually like to start with one linear and one nonlinear algorithm. Which ones are linear or nonlinear? How do you know? Let me tell you a great resource that you should know about. I'm going to open up a new tab and go to aka.ms Azure Machine Learning Cheat Sheet. This is an amazing resource that was put together by one of my friends on the Azure Machine Learning team, and he has done an amazing job of giving you a great exploration of starting at this node, what kind of problem are you trying to solve? And then it gives you very discrete, wonderful, kind of tells you what each one is very good at. So let's just open that up real quick, and I can show you very quickly what this looks like. So now you can see if we start right here, we know that we want to predict a category, right? We want to predict yes or no on whether it will do, whether the Titanic, whether the passenger will die on the Titanic. And then, so we would go here, and then how many categories are there? There's only two, survived or died. There were no zombies coming off of the Titanic, so we have two discrete categories. And then here it shows me what are each of those algorithms good at. And we kind of have the linear ones on one side and the nonlinear ones on the other side. And so you can see that, for example, SVMs or support vector machines are very good when there's a lot of features, over 100 different features or inputs into the algorithm. There are some that are good that have really fast training. There are some are good if you have a very large memory footprint. So you can take a look at these and actually thinking about what kind of data you have, choose the best one for your needs. And again, the best way is really to just explore, but this Azure Machine Learning cheat sheet gives you a great place to start. All right, so I'm going to start with one linear and one nonlinear one to see which one kind of performs better on my data. So for the linear one, maybe we'll do like a logistic regression is a good one, and then we'll do maybe a decision jungle on the other side. I like to do a decision tree as well. So let's go ahead and do this. All right, so I'm going to split my data. I've split in my data, and I'm going to grab logistic regression, I said, so we'll grab one of those right here, and a decision jungle right here. And so I want to build models with these two algorithms. And if I click on either one of them, there's a whole bunch of different parameters that you can set here as well. And so let me, what I'm going to do before I get into the parameters, let me show you how to go ahead and train one. And there's a wonderful tool that you can use called Sweep Parameters. Now this is a great, a really great resource you can use if you don't know what are the good initial variables, how do I know what to choose. Sweep Parameters is great because it will send in a range of parameters for you and then give you back, it'll try a whole bunch of different initial variables and then give you back the model that performs the best. So that's a great thing to use if you don't really know what's going on. In this case of this particular scenario, the defaults work pretty well, so I'll just go ahead with the defaults, but do keep in mind sweep parameters is a great thing if you don't really know how to modify these variables. Hook up a sweep parameters in between this in your train model. All right, but I'm just going to go straight to train model right here and stick one right here and one right here. So I'm going to build two different models. And this is a great, let me show you this map right here since it's kind of ready. It's kind of exploring for me. This actually gives you, when your tree or when your data flow here in machine learning workspace tends to get very large, this is a great way to help you kind of navigate around what we're doing. For right now, it's kind of getting in my way though, so I'm actually going to click it away using that button. So you're welcome to do that as well. So now I have these different algorithms, and so what I want to do is tell it, okay, this is the algorithm I want to use to train my data, and then this 70% of the data was the data I wanted to use. And then here in the train model, it's asking, okay, what is my label column? What is it that you want me to predict? So I'm going to launch this and tell it survived. Survived is what we care about, whether or not they survived the Titanic. All right, so that's what I want it to predict. And then I'm going to do the same thing over here where I wire up the decision jungle algorithm, and I wire up that same 70% of the data to train with, and then again tell it survived is what I want it to predict. All right. So now the output of this is a nice trained model. But now I want to see how well did it actually perform. So I'm going to go here to the score section and grab two score models. And what this will do is we'll be able to take that test data that we held back, that extra 30%, and feed the inputs into the model that we just trained. Then we'll get those outputs and we can compare them against those known right answers that we actually have in our data. So I'm going to take the trained model and pass that in. And then I'm going to take that 30% of the data and test using this, and then do the same thing over here where I take the trained model and the test data, and I'm all set now. And then finally, since I have two different algorithms that I'm trying this data on, I want to see how well did they actually do versus each other. You know, which one should I go with? And so to do that, I'm going to use an evaluate model. And so there's an evaluate model right here, which you can use. And now I'm going to pass in the logistic regression model, trained model, and then the decision jungle, and we'll see how well these guys perform against each other. All right, I'm going to go ahead and save my work, and then we'll go ahead and run this as well and see how well our models perform. All right, so we're almost done with our evaluate model. There it goes. So now what I'm going to do, I'm going to right-click the output node of that evaluate model, and I am going to visualize what my data looks like. So now it actually shows me an amazing visual display of exactly how well those two models performed against each other. Now the first one that comes in, the left-hand side is the blue, so that's my logistic regression, and then the second node that came in the other side is my, or my right-hand side, this guy right here, is my, decision jungle. So if we look first at the linear regression, which doesn't look like it performed quite as well here. Let me tell you how to read this chart. So what this actually gives me is my true positive rate versus my false positive rate. And so this line right here that you see across the middle, this diagonal, is essentially 50-50 random chance, all right? So, you know, monkeys throwing dice would predict, you know, the right answers, you know, 50% of the time for whether or not someone would survive the Titanic. So you want your model to be performing better than 50-50 random chance, right? And so this kind of tells you how much better it is going. And so perfection, if you've got everything absolutely correct, the line would go all the way up here and then all the way across like that. So we really want to have as much area under the curve as possible here. So just looking at this very simple demo where we did not do very advanced processing beforehand, if we check the very first one, you can see we got 79% accuracy. So to read this little section right here, it gives us the true positives and the true negatives. You want those numbers to be high. It gives you the false negatives and the false positives. You want those numbers to be low. And then it gives you numbers for the accuracy, the amount of recall and precision, and then an F1 score, which is a combination of recall and precision. And then kind of all of these together is your total area under the curve, or AUC. And that's 83 or almost 84%, which is pretty good. And so you can see, just using default parameters in Azure Machine Learning and not doing some very advanced, did very minor data processing and data cleaning beforehand, we were able to get 79% accuracy. Now that's not bad, considering, if the problem that you're trying to solve is something like, will one of my customers actually buy this product? How likely are they to buy it? If you can predict whether or not they'll buy it, 80% of the time, you're doing pretty well, especially if you know like zero. If what you're working with right now is 0% of the time, having that knowledge. So really good, accuracy we can get here fairly easily. And it also breaks things down into scoring bins as well, so you can kind of see what it looks like through the distribution of your data. All right, so our decision, our logistic regression gave us about 79% accuracy. We can also click on the other one, the decision jungle, and that one performed, it looks like it performed a little bit better there, and oh yes it did. So this is 81% accuracy. So not bad. So both of them are giving roughly 80% accuracy for not a ton of work. So that's pretty cool. So what I would probably do in the real world is tweak this a little more. I'd try different algorithms. I'd mess with the initial parameters, which you can do using that sweep parameters and other mechanisms as well. But once I found one and I'm happy with it, I actually want to deploy it out to production. So let's say I'm happy with this 81% accuracy, and I want to go ahead and deploy it. So what I need to do is select the one that I actually wanted to deploy. So in this case, I'm going to select the decision jungle because it performed a little bit better. And then I want to set up a web service. So I'm going to go here, and what you want to set up is a predictive web service. The retraining web service will allow you to rebuild your training models. But for right now, I want to do one where I can send it data and then have it send me back predictions on whether or not these people would survive. And so I'm going to click on this, and then what that's going to do is set up for me a testing experiment where it gives me, ooh, nice animation. It gets rid of kind of all the training work I was doing, creating a training and test set and that sort of thing. And instead it leaves me with just, here's a new web service input. So a web service will be exposed with a REST endpoints, so I can call it via REST with the data, the Titanic demographic data that we saw before, and get some information about the people. And then it will apply that same data cleaning that I was talking about. So all the data cleaning that we did in part 1 of this tutorial is retained here. And then it actually uses the scored model. Here, let me zoom in for you a little bit. It actually uses the scored model that we saw here to predict. So we see all of our data cleaning right here is the same, predicting columns and all those metadata editors, and then it takes that thing that we built right here, our trained model, and is using that to score, and then it will provide that to a web service output. So very easy to deploy. I do have to run this once really quickly to get it all wired up, make sure everything is flowing through just fine, and then we'll actually deploy it out. Now, the deployment process is essentially a button click, so it does make it very extremely easy. If right now, like current issues that you have with machine learning is that it is fairly easy to, or pretty hard to get out and so now we want to actually deploy this out. I'm going to click on this deploy web service, and then that will actually deploy it out to an Azure and expose it in Azure and expose those REST endpoints. And so now, to be able to call this website, you need to have the API key. So I have an API key that's here and available, and so I can put that in my application so that my application is able to call, and a random person wouldn't be able to call this particular website. Now, I do want to show you the documentation that's generated here because it is very good. There's actually 2 different ways to call the web service. You can call it in request response mode, where for a single person on the Titanic, let me send one person's information and then I will get back yes or no whether they survived, that sort of thing. So you could do kind of single request responses. Or you can actually do batch execution, where you essentially say, let me send you a whole CSV of a bunch of people, and it will process all of those and then send you back a CSV with all of the responses back. So it's really good. Depending on what your needs are, you can call the web service either way. So now let me show you, and actually let me show you the documentation too, because this is beautiful. they really did a good job in making it very easy to operationalize this. So now what this gives me is here are the exact post requests that I would make to be able to call this web service. So it's giving me the exact URLs. Here's what the request header should look like. Here's a sample of what a request body could look like. Here's all the status codes that you would see, the response back. The input parameters, it gives you all the information. By default, we can actually change this before we deploy out. I didn't do it in this simple example, but you can actually, by default, it sends back all of the inputs that you passed in. It sends back all of those as outputs as well from your web service. But if you don't want it to send back all of them, if you have like a unique identifier and you want to kind of strip out everything else and just send back like your ID plus the prediction, you could do that as well by using a project columns to remove the stuff that you don't care about. So you can see here it's giving me all of my data. Here's what it looks like. Here's the data type. And then here's even the allowed values that it was able to extrapolate from my data. So really, really nice documentation that was auto-generated for me for someone who wants to call my service. Very, very nice. Then you can see it actually gives you sample code in 3 different languages. So if you are a C# person, you can grab this code right here, copy and paste it into a console application, and then just run it, and it will call your web service for you right there. And then there's also Python code and R code available. So one of those 3 languages, you can just be up and running in 2 seconds, and then any other language, you can still use it. You just have to kind of call those REST endpoints yourself, but not the hardest thing. There's a ton of libraries around calling REST. All right, so that's what we can do here. Let me jump back here and show you. I kind of showed you the documentation which you can get if you can click on either one of these. Now let's actually show you how you could test it. Now you may be a developer or a data scientist, but maybe you work with business analysts or someone who want to use your service but don't necessarily know how to code or the mechanics of data science. Well, we've got a couple of really cool options that we provide. So one way you as a developer could just test the service quickly is by calling this test button. And so what it does is actually gives you, here are all the things that I want to call, and you have the ability to just kind of test it right here. So let's give this a try. I'm going to do, so there were 891 rows in my data, so I'm going to do passenger 1000. So this is a passenger we have not seen before. And then survived, we don't know, so I'm going to leave that blank. Let's say that we have a first class passenger, and her name is Rose, and she is a female, and her age is maybe 20. I'm not really sure how old she was. Siblings or spouses, she didn't have any. She was engaged, but I don't know if that counts. I think that's no still. She had a mean mother, I think, on board, so let's do 1 for parent and children. Ticket number, we saw the tickets were kind of gobbledygook, so we'll just kind of put something in there. The fare, how much she paid. She was doing a first class ticket, so it was probably one of the more expensive fares. Let's say she paid $200 for her ticket. Cabin, she probably had a cabin. We're not actually using cabin in there, but let's give her a nice cabin in there. And then embarkment point, I don't know, but let's just use S since it was the most common one for Southampton. All right, so let's call that. And what it will do right now is it actually calls the web service, and then it gives me a response back, and I can see all of the data that I passed in here. And then the last 2 parameters we have are the prediction, yes or no, and then our confidence in that prediction. So you can see the number here that was returned is 1. So yes, they predicted that Rose survived, which is correct. And then they were 98% confident that she survived. And for a female in first class, I think that is probably fairly likely that she would. Now, the other way we can test that is using these Excel spreadsheets. Now, these are incredible, especially when you're working with your business analysts and other folks on your team who may not code or who want to consume your web service without a development or data science background. So what you can do is give them one of these Excel workbooks, and I'm going to click on this one, for example, and I'm just going to save it locally first, and then open it up. And now, since I'm downloading something from the internet, I'm going to have to enable once to say, hey, this is something that came from the internet, but that's all right with me. And so I'll do my first enable right here. to, yes, enable editing since it came from the internet, but I know it's okay. And then I have to hit it again, secondly, because it's running macros. And when we have macros running, we need to explicitly say that they're okay. So now, this Excel workbook is already wired up to call your Azure Machine Learning service. It is using that access key. It has that access key already embedded in. It's using that to be able to call appropriately. So now what I'm going to do is let's try it again. Let's use the opposite case and put poor Jack in here and see if he survives. So I'm going to do a new passenger ID. Let's do 1001. Survived, we don't really know yet, so we'll do, let's even put 1 since we know that's wrong and make sure it can give us the right answer back. For the passengers class, he was a 3rd class passenger. His name was Jack Dawson. Gender was male. Age was maybe 23, I'm not really sure. Siblings or spouses, nothing. Parent or child, we have nothing. Ticket number, something like this. The fare, he actually did pay 0 because he gambled his way on board, right, in the movie? Is that how it worked? So we'll go with 0. Cabin is probably blank because I don't think he had a cabin assigned. And then for the embarkment point, let's just do S again because it's the most common. And so you can see it actually, since I've changed all those values, it actually did call, and because I'm getting all of those things passed back right here, and you can see I have a scored label where it predicts 0 so that he will not survive, a 3rd class male passenger. And our probability there is about 28% confident, all right? So again, it made two different judgments for both Jack and Rose. We were able to see whether or not they would survive the Titanic. Okay, so we also saw how amazingly easy it is to use Azure Machine Learning. Here in Part 2, we actually took our data, applied machine learning by splitting the data set, applying different machine learning algorithms, trying them out, finding the best one, and then creating and deploying a web service out there with REST exposed and actually going all the way to call that web service as well. I hope you enjoyed and learned something about how to predict the Titanic and to use Azure Machine Learning. Thank you very much.